I'm Domas Mituzas from MySQL and some microsystems right now. I also do some software engineering and performance engineering and database work on MediaWiki, the Wikipedia software, and the Wikipedia platform itself. And also did assist quite a few open source projects with their database interaction. And so I ended up coming up with a talk about simply how to use MySQL in a practical way, how not to make some crazy mistakes, what is the good way, and especially how that all fits in the MySQL, into the web world, into the web applications, which immediately provide someone different approach to doing lots of things. It is different from the textbook example, different from the theories. It has evolved a lot in the past 2 years and not in the past 30 years. So all this web thing is so new that we simply have to rethink some of the issues that we are having in our applications. And here we'll try to cover some of these things. First of all, this is a different world. This is no longer analytic processing. This is no longer transaction processing. It is all about providing the data when people need it. It's slightly a bit about allowing others to participate, but it's the major topic of the web applications, web databases, is that it is simply online processing, online web processing, which has completely different rules from in terms of how you should structure your data, how you should query it, how the application should interact with databases, and indeed this becomes slightly different world that we were used to. And the major things about the web, everyone needs data now. Whenever someone just clicks any links, it becomes immediately, they want to get responses immediately for every click they do. Every wait, every second makes people frustrated. And there is nothing easier than just closing a web browser and going to some other site that responds instead of us. It's like right now, everything happens right now. It's like thousands of, millions of people can just jump in at any second, and all the application environment, all the web structures, they all have to be prepared to serve that. It's not like we can have calculations for them provided at any time later. It has to be prepared now for every click, and it will be repeated, and people will come and ask for same data again. And that is already where it becomes quite different from big transaction processing, where it's usually about changing, about adding, inserting, deleting data, but much less about querying that in huge chunks. And especially, it's not like it's that repetitive anymore. So this comes from why MySQL shines in the field. It is great network Bitbucket. I mean, we can talk a lot about all the advanced features and triggers and optimizers and subqueries and whatever, but what MySQL does great is simply it allows you simple create, replace, update, delete operations, and also it allows quite efficient fetches of that. It is quite lightweight layer on file system compared to other solutions. It just simply locates the data, it takes it and just gives it quite fast. Whenever you try to do something more complicated with it, you might end up with a bit of other issues, like it becomes slower. So for the web kind of flow, that means that we have to enjoy what MySQL provides to us. Which is, okay, I'll start being a bit of marketing kind of speak. Generally, there are a few features in MySQL which make it slightly better for exactly the tasks of web. So say InnoDB does the data clustering, which groups data together, and we don't have to care about efficiency of fetching the records when it's all done by that. It allows covering indexes, which allows just index-only reads instead of going into tables and seeking the disk. And this is what one of the major optimizations for the web environment is. It's avoiding seeks, avoiding hitting the disk, because disks rotate just 150 times a second or whatever. Okay, the high-end disks rotate 200 times a second, so that's only that much how we can fetch the data from disk. It doesn't facilitate thousands or millions of users coming. So using some of these things that inside MySQL, make it much more practical for the use. of course, the other major thing with the web loads and like how MySQL works there, it's really easy way. It has really efficient way of doing the index order reads, which is something where it allows you to specify in terms of indexes how users will need your data in which order, which forms, and simply just that especially efficient just to provide the data to the users. And this is where the specialty of the web environment becomes. We usually don't want to limit our users. They come from everywhere. So we just have the magic like 255 character limit strings everywhere. And it's not bad. It's not like by providing this size, we end up with a huge amounts of data where everyone just, checks the counter on a form and tries to fill in all 255 bytes just, to make the database faster and database admins more happy about it. Like if we take a look at, say, any data kind of or user supplied data distribution, and when we allow them 255 bytes, we end up like seeing like huge mountain at like 10 bytes of like most of records are just 10 to 15 bytes or whatever, and those like the small area with like those short strings in every huge field, they make just a huge amount of it, which means that even if we allow users, they're really lazy and they will not type that in. It means that whenever we talk about 255 byte strings, we usually mean 10 byte string in the mind. It usually means that if we have a table where such field exists, instead of having like all the white in the like multiplying number of rows by 255, we just have to do the average map, which is like 10 or 15, and the average user inserted string is actually taking sometimes less space than the integer values of it that we provide in them. So generally, even though we like in web environments, the whole data is provided to be like allowing lots of freedom, lots of space for everyone to like to communicate, participate. In the end, they are all just end up with small bytes, small fields, small data, and this is where completely different ways to handle that data begin, which is like indexing, structuring data, and there have to then the various hacks have to be done just to facilitate that process of dealing with it faster, and we can take that into mind that it's not that expensive than we used to think about. And access is like the access pattern usually to web data is completely different from other applications. Here the changes are small. It takes a use like in web environments where there is communication, participation. Still, it takes a human to type in the record, and that is the major bandwidth usually in any application. As long as you have users, like more users you have, you're more happy you are. But like the major evaluation of how to plan the whole application is simply how many users you will be having, how fast are they typing, are they Twitterers or philosophers. So that's already quite different approach to how to structure the data. And usually the writes are small, they are rare, they just insert and nobody changes text. Say the major way to handle like big in databases is say having a users table and just have every user get its own ID and just join it whenever needed. But nobody changes their username that often. Not that many sites even allow changing usernames. It's much easier if someone has offensive username. It's much easier to block it or to remove it. So like, why would we want to have all this dynamic approach to accessing that data which never changes? So understanding that we only insert data and we write in small batches, it's already quite different from providing that kind of transactional approach where lots of things change and we have to handle all that. It's more about reading, more about accessing the incrementing and more incrementing the data sets. And reads are big. They're bigger. Of course, they usually, the main idea is to fill the screen with data. It's like no web view actually gets megabytes of text spewed out to it because not that many of us can read that fast. So it's usually always accessing just a small range of data, but out of big data sets, it has to be all optimized for the idea that whatever user needs is like we really know what they want. we really know in what order they want, and we can really specify that, because that is what the whole like website business is usually about. It's like we know where we want to lead the customer, where we want to lead the user, and how we should provide the best tool for it and best environment for that. So usually the data is ordered always. Users don't like seeing unordered data. So that is the number one thing we have to always have in mind. Users will really want to limit their approach of seeing the data, which is also always having just defined limits of what they want to see, instead of just randomly poking somewhere. And of course, there's limiting of the data. You have always just pages instead of like big megabyte arrays of data that nobody looks at. And indeed, every application knows the view pattern. How is the data will be accessed? Is that accessing something what the user has done? Is that accessing some tag information or category? Is that just following some timeline? But that is always completely specific to that exact application. And preparing for all the various other ways that, preparing data to handle thousands of other kinds of ways to do the data is usually a huge overhead. We just have to do the apply that that access to the data just simply by few ways. It's like not that many. Usually, like everything in the web world is structured in a way that is completely like uniform, and every hit it becomes uniform. And this is where we start going into the practical bits of how to handle that. First of all, file sorts are completely bad, terrible. Like whichever like big site guy you would talk to, he would hate file sorts, which is like ordering not based on index, which would like force MySQL to do double, triple, or like 10 times more work than it's actually returning data that lies in this ordered fashion. And even like if you have some text or blob fields in there, the file sort will immediately go to file system, and that already becomes the issue, which hits not only big sites, which don't really want to have much of file sorting, but usually that also especially it hits small applications, like web applications like WordPress or whichever. If they do that, they usually are in shared environments with the disk I/O resource, and that the resources are so far more limited. So by switching from file sort to index order read, one could reach 20 times better performance or so. And here again, why do we have to file sort for every user when we already know the order that users want to access data in? And that is one of the major critical issues there. That doing file sorts whenever they show up in any web application, it has like every time you have to find out the developer who did it and try to speak file sorts about like 10 or 100 times in a row just for him to understand how evil he is by doing just that. And indeed, like whenever, like even in cases like say in Wikipedia case where we have few queries which have file sorts, so what we do to them, we just send to another server so that it wouldn't come to the main servers that handle thousands of queries per second. And this is like where in MySQL you really don't want to mix really fast operations, which are the web kind of things, with some reporting queries. It's like allowing an elephant to go into a highway, and then it's like, of course, there is still some way for cars, but everybody will start looking at that elephant and be scared of it, and it would still block far more roads than any others. It would move so slowly that it would get out of the highway just in a week instead of an hour. So like the exact same as with big queries like if you have really optimized flow of information going on to all the users serving all the time, it is always important to understand that anything slow there is bad and has to be like killed or eliminated or moved somewhere else. And of course, indexing. Over-indexing in web applications it shouldn't be that frightening as long as indexes are used. Generally, in many applications like WordPress or MediaWiki or others, we would end up with simply providing an index for every command viewed in there. Like if we know that this page is like, like 99% of operations, even more, have to be like completely indexed for exact query terms that are provided in there. Because otherwise, instead of like returning 10 rows to user and scanning 1,000 rows or 10,000 or 10 million, it doesn't get that efficient. So it's like every query that is in there should be like completely aligned with the indexing. And what to do if there is no index there for a query? Just like there are really simple solutions. A, not do that query, which is usually ends up in nice debates with the developers. It's like really simply understanding that index for that query is quite cheap compared to recalculating all the time. And the update patterns for any web application are quite limited to like just small row adds every time. So it's not like we are going to cause huge data reshuffling every time you add the record. It's all small incremental changes and then returning the data in the optimized fashion, index order. And that's exactly what database is made for in this case. And especially like how MySQL operates internally. And really it's one of the issues with, say, file sort. Until 5.1, which is, there are rumors that might be released someday.
I have a question for you. You said like order, the previous slide, order by, you said it is going to do the task. The thing is that is not true with the last couple of releases of new optimize the way you can hit to the order by only using because the big tree already has a solid base in the Expo, like it's not the case.
Yes, like order by limit. Yeah, order by limit optimizations, like usually if you use index, if there is index for that, it will be like 10,000, it will be 1,000 times more efficient. It's like whenever you follow index for that, it's really efficient operation. Whenever you don't have any, it will like sort huge sets of data and then just to get like 10 rows, which is like something what happens quite often in various applications. So indeed, the issue with file sort in 5.0 and earlier MySQL releases is that it would allocate the full width of the field. Like it would, instead of making kind of dynamic length rows in memory, it would align static rows in memory. Which means that, say if you're using Unicode on a varchar 255 byte char character long field, it will end up allocating 700 bytes for every row just for that field alone in memory to facilitate the file sorting. So as the data is, if the file sorting is based on if you need order on the text field that users type in, it's always just better to create an index for that and avoid any kind of file sorting all the time. So it's like over-indexing in any web application. It's usually worth it for much more, and even if indexes take 3 times as much as data, it still in the end provides much more performance than it actually causes to maintain them. And of course, composite indexing is the usual way to handle so many situations. Like the major mistake with web applications that come in, like fresh ones, is that putting index on any field and that's it. It's usually that does not facilitate multiple field returns. So it's always, it must be like every query, if it asks for 3 field information, like user category and whatever, it has to be like full width, and even more. If it's the indexing itself should facilitate not only where but also always order by, which is usually if you ask for 2 where fields and for 2 order by fields, in the end it can end up with 4 fields in the index, which isn't bad. It might be even covering the whole table, but it provides much easier access for the reads. It's lower for the writes, of course, but that's not what we care about usually in any environment which needs the web kind of load. And this is where InnoDB becomes quite interesting with this internal storage. In InnoDB, every record is just aligned to its primary key, which means that whenever you increase the primary key, the storage of the record does not increase in space. Of course, the tree structure becomes slightly fatter. There are more requests to read those tree nodes, but that's usually all in hot memory. So having the more fields in primary key, that means grouping, that means better sorting, that means that every kind of scan of records by primary key will will return better ordered data, and that is quite often very much needed for nearly every application. And this is where the major hack comes in. For every other index, the primary key values go into it yet again. That means that by adding fields of primary key to secondary key definition, there is not that much of overhead because that data is already in there. But instead of like getting in random order, you end up getting records reading from a secondary key in your defined order, how you want that, by primary key values. And this is especially useful in so many cases where like simply adding more fields to the key is not causing any more overhead. So that especially is useful in category mapping tables where you have like 3 fields in a row and like primary key already has 2 of them. So you can just expand on primary key to contain 3 fields, and if you create another index in opposite order, then it becomes, you can here again add all 3 fields in different order. So essentially have different, really fast hash matching tables for all the various queries that have to be done on the like per category basis. But in the end, that it doesn't cost you at all because the data would essentially go there anyway. In narrow tables, it is really cheap to maintain multiple views of it in indexes that fully cover the table. So even when you ask for information from the index, it would just scan the tree structure and wouldn't go looking for records somewhere in other areas. So that is like, and this is another trick with InnoDB. Once you have wider indexes that define clearly the order of the data, every read of it is already in order by in a joint order, which is quite good thing when you come to joining multiple tables, as every join comes in already predefined order by the index that it is joined to. So if you just need to join by single field, but you want to order your data, like adding order by on second or third table in a join until 5.1, it will cause file sorts all the time. So simply by having those implicit order fields in the indexes, it slightly increases the cost of maintaining the index, but it also makes the join itself ordered on an implicit basis. Of course, sometimes it's better to use force index in that way in case you have multiple indexes. And any database theorist could shoot me for these words that I've just said, that I could rely on implicit orders of the field. And the covering index feature is one of the most nice optimizations in there, because in larger sets or in any set that doesn't fit in memory and any set that doesn't go to solid state disk, I don't know how when these will become common, it might end up in 100 times faster queries, because instead of like if you read all fields just from an index, it can, instead of 10,000 seeks, it can do just 10 seeks from the disk. And that's already a huge performance benefit. Like on live site, we had some of features which would ask for data in just different order than primary key, and going and seeking every record from this would take minutes. And when we just added all fields, that was actually adding like 10 fields to the index, but it ended up that our return queries became 1,000 times faster. And this technique is really, it helps sometimes so much that people don't really imagine that, especially it looks so scary when you find out that you're adding like 1,000 bytes of index nodes. But this is something where exactly MySQL can shine, and we're optimizing for that as like a huge benefit. And really, I don't know how that will work with solid-state disks, but right now it's an amazing issue. So here again, the join orders. In 5.1, it's fixed. But until then, every time, like even if you fetch a single record from a table, or you start to join, say in normalized environments, that is usually okay, get me user ID for a user whose name is John, and then you use that user ID for fetching his record from another table. And then we of course want to order data by the second table, but MySQL Optimizer didn't think of it too well, and would always use file sort if the order by field would not be on first table, but would be on any other in the join. So 5.1 is getting much better in this regard. It already does the same decision there, but until then, real performance degradation. It would be much easier sometimes just instead of join, do the application level join and fetch the records into like application and then use some user and then do the kind of application level join and say all user IDs back and send back to the database. But that would eliminate the ordering and would be like that was quite a common problem in so many applications that like babies start crying when they see that. So and indeed, like as I told before, as any index read from InnoDB is already ordered in some way or another, you can simply add to work around these cases, one can add ordering field to the index itself. So one of the famous hacks was like for category linking, we used to have the reverse timestamp field, which was simply adding an index, which beside the category ID, it would have timestamp in reverse order. So every time we just ask for data based on category ID, it would always come in the reverse order. And we didn't even have to use order by, and if we use order by, it would just kill the performance entirely. So using these tricks that every time you just join based on some index, it will come in the index order, is kind of like walk-around approach to the practical limits of MySQL, how it does the ordering. Yes, please.
When you use an index to get an order, you're also using the index to go back and forth to the table. There's no effect for doing that. Often sorts are faster. For example, one of the fastest ways to build an index is to sort the keys first. So sorting is often faster than using an index. Wouldn't that be true for MySQL since it's true for other databases?
Well, that is the seeking, like index-based seeking, is quite difficult when you have like data scattered across the disk. The issue is when you're joining the data, you still need the data. You still have to go and fetch it all. And when you say that file sorting is faster, it's when you have whole table scanned and then you file sort that. But if you have to take out 1% of rows from a table, then it's usually just faster to do the seeks. Or like read up from, like if they're cached in memory. But that's quite valid in case your data sets are huge and you don't want to jump along them too much in case where you have like thousands or 10,000 of rows to fetch. But usually you're just showing 10 rows or like 100 rows to a user. And this is for already reading them, like you still have to seek to the positions in memory to get those rows. So you already have that overhead of seeking. Then if your orders are coming already, like if you read ordered rows, then you don't have the file sort overhead. So it's of course like everything we're doing here has trade-offs. Like in some cases, just doing other method is more efficient. But in major views in application design, it's usually better just do the index order reads, especially when it comes to in memory, like really hot areas where like jumping around randomly is it's already like really efficient. So indeed, like these hacks around ordering, they are like they saved us lots of cycles on like I/O and memory and CPU, and like could allow us to do some of the things that were impossible before simply by doing these hacks. We could just have really efficient way to fetch that, and that is. And this efficiency thing is like not going to disk, not causing sort, not causing like much higher cost. It means that every query, either it is application running on shared hosting environment or it is some really huge high performance application environment, it still has really distinct performance, which is can be like 10 times bigger or even more. So like talking about these hacks can get me fired because like usually the database engine should be always whatever you provided to do the most efficient way, but optimizers don't work that well, especially in older versions. So if you use it, of course the major issue here is you have to understand what this does, and implicit ordering, if it picks another index and you don't have an order by, then it will end up providing data in different order, and that's sometimes not what you want to do, so forced index helps. And this is where we have often the debates with developers who end up turned from universities and they just had the database course, and they say this is not elegant. I don't care about elegance that much because elegance costs us a lot. And that's usually, but it's easier to develop on elegant databases. Maybe, but it's not easy. It's easier to run them. So the whole idea with the web application is that you prepare the data and store the data where it is needed, not where it is elegant. Because no user cares about the elegancy of how everything is happening in the background. What user cares is that he gets, like when he clicks, he gets the answer. And that is, essentially people have to bend their minds and go from elegance to simple, from something what is really nice on paper and really nice in theory to something what is easier for database to execute. And this is again trade-off management, but it's usually whenever you have lots of read, really high performance environment, or like you want your application to be snappy, it's like instead of like being really elegant and having nice code with comments or whatever, you better have something which is really fast. And see, one of the most not elegant things is denormalizing. Like you said, denormalizing, and so many database theories just start like feeling so unhappy about it. But essentially that is, here again, if it is bigger data set where data doesn't fit in memory, simply storing a field that doesn't change but is repeated and is against normalization theories, it speeds up things a lot. And joining the table all the time just for a value that it doesn't change. Does one need to do that? Well, the elegant way would be like storing it all and having all those nice IDs mapping each other. But whenever you have to do ordering on those fields that are repetitive, you have to keep it in single data because MySQL will lower and other database engines will not be able to both look up data from one index, use another index for ordering. That doesn't work that well, especially if those indexes span tables. So usually the major issue is that index, there is just one index which is used for where and order, and this is why it's having field another table that you want to include in where or efficient order condition. It doesn't work that well. So it's easier just to put everything in single pile and just serve it from it for the users. You can use the elegant structures in the background to form those ring buffers of like really hot data you serve to users, but essentially still the users hit just prepared data. They don't want to do the calculation happening at the time they click, and that's where doing that, and that's where we really have to sacrifice some things. And of course, that's heresy in other worlds, and people might be having fire, like sent out of universities and not allowed to come to database classes again. And this is like, this is covering the query cache, which is really loved feature by everyone who sees MySQL, but doesn't try it too much. Query cache is great in case you have small application that doesn't change its data. Say some blogging application that lives on a shared hosting. If that shared hosting has enabled query cache, it will really benefit from query cache, because like nobody really adds data to the tables. It's like invalidated on every table change. So as long as tables don't change, it can be efficient. But whenever you start using transactions, query cache doesn't work. When other changes start coming in, query cache doesn't work. And query cache isn't the solution to many things. The very simple fact about databases is that they have other caches too. And if you're not hitting query cache, it's not the end of the world. There is also a key cache, InnoDB buffer pool, there are various other buffers, and you don't really die when query cache is not used. But for niche cases where data doesn't change but lots of reads are done, it's a really efficient and easy way just to forget lots of the caching layers in the application, just leave it to the database. But for that, there are a few major issues. Queries doesn't have to change, transactions don't have to happen, and of course the queries have to be as uniform as possible. A single difference of some parameter addition to it immediately breaks the use of the cache. And of course, the very common problem is that people just like to count fields. As if anyone cared about counts. I mean, any averages can work, any looking at those fields, like counting is just simply traversing the list, traversing indexing, traversing tables. So, of course, MySQL managed to spoil lots of users simply by allowing select count star from a table, and it's incredibly fast. So, does that mean that counts are fast for every view? It's like, no. And this is where like scanning grows, it becomes really inefficient, and I know DBA doesn't even have that kind of hack. So usually applications, whenever they want to count members of categories, count numbers of changes user made or whatever, it's better just to store it in the table somewhere. And it's really easy with MySQL. You just do insert on duplicate key, and you just update, increment the counter if the field is if data is in there. It's like it happens on every change, which is like 1,000 times or 100,000 times less common than actually the views that come to that data. So, like anytime anyone does select count star on a field in a web view that is common, he's making a huge mistake, and that's something that should be always, that would never happen. Now, that's also the usual question. People like to keep blobs inside tables along with the metadata. But that is like most wrong approach to do that. Simply by putting a blob on another table, one gets rid, like, you don't have to read those blobs anymore for sorts, for grouping, and for large scans. And it's quite good approach even for application to split the blob lookup from the actual metadata lookup, because metadata can usually, it's really those metadata queries searching for something, looking at grouping, counting. They are always much more, they scan much more data, and blobs are usually used, they're never used for lookup, except like in full text search, but that's another issue. They are usually just used for display logic. And having display logic and the lookup logic ends up not that efficient when it has to be like scanned all the time. So just having a separate query for reading blobs ends up not only having more efficient all the queries, but also allows in the end to move those blob storages or like text storages to external methods, let it be file system or some distributed storage cloud or whatever. And of course, the usual problem of the paging. MySQL introduced that simple way to page data. It is like limit to that number of results and offset by that number of results. And so many people use that. And that especially gets bad when you have to skip 1,000 records just to read 10. And whenever there are lots of more and more users coming, more and more data is in there, those people start like thinking, adding like links to 15th page. Like, I've never needed the 15th page. I don't know what is in there. Like, it's not a natural way to see the data. The natural way to see the data is either go by date or by my last visit or simply next and previous page. It's not, especially when the 15th page doesn't have the static list of data, like every time you can come to 15th page, it will have different data. It's no natural way for users and visitors to go there. So from one side, who needs paging, but of course, as in like jumping to some specific page, but in the end, the good approach is simply taking some index position and scanning 10 records from there with a limit clause. And we end up like, in any practice, like it's so common problem, but in the end when it is done, it's so much faster. And this is the character set part, which is like, of course, really common, that it deserves another talk, which I hope will be less boring than this one, but it will be tomorrow. The idea about it is, in the Western world, everyone uses Latin 1, which is actually in MySQL, it's not Latin 1, it's CP 1252. But it doesn't differ that much. But the whole idea about character sets is that people are used to simple things. And suddenly all these international users come in. So adding Unicode brings up so many additional troubles that it's like everyone who can fit in Latin 1 is really happy. because the fields are smaller, memory allocations inside MySQL are smaller. But if you need Unicode, you really have to understand that this is where file sorts become even more expensive, and this is where all the data lookups they become like use like 3 or 4 times more memory. And like, of course, in MySQL 6.0 it will use 4-byte Unicode characters instead of 3, which is yet another issue to take care of. And here again, connections. In the web world, everyone loves persistent connections, though they don't help. The connection cost usually for like once you turn off the name resolutions and just use IP addresses for connecting, it's like minimal. And when the thread cache is in there, it's like it takes less than a millisecond to connect to database server. But people end up still pooling those connections, and every thread that has ever used database, it ends up using a connection. And again, and MySQL connections right now are expensive. They might not be that expensive in future. Here again, it's in wide open 6.0 or whatever. But right now, whenever you need a connection, just get it connected, do your work, and disconnect as fast as possible. Because that's one of the resources that is quite expensive in terms of memory, in terms of allocated buffers, and simply in terms of the kernel overhead. And in web applications, once they are properly structured, you use properly indexing and so on, I've seen it spends in database just 10 to 20% of their time. So it's quite often useful just to disconnect after you do your work. And this is where restructuring a bit of applications to use the efficient database kind of connectivity is quite easy. Like you do the initial setup and all preparation for the actual work before. You do a few queries, you build the data set afterward, like in the middle, instead, and then just disconnect and start sending out the data to the customer. And the major problem that we've seen is that people start streaming MP3 files or whatever and still hold the connections to the user. The major thing is don't ever try to block the connection and wait for something where user can affect the length of it. Yes, please.
How do you deal with multi-row transactions? Or, let's say you have an isolation level where you're going up to repeatable reads and serializable, and that's the only way to solve the problem. You have a problem where the user must know these rows are not changing while they make a decision. How do you deal with that? Because it doesn't require a connection unless you're going to implement everything in the database already done.
It's holding connection for the page view is all perfectly valid. It's the bad thing is when those connections span multiple requests, or when you hold the connection, when you do lots of like expensive things outside, like streaming MP3 file to a user. Like if you hold the connection, and especially if the transaction is open in there, sending that data to and then malicious user would acquire some logs somehow and would just stall the browser. And that connection will be in there, open, with all the logs, and it can kill lots of other site execution. So it's really usually just better batch more thing to do at the moment, handle as much of locking at that time as needed, and then just release that once you just start flushing the data out to customer. Because in most of web views, you already know everything before you're sending out the data. So output buffering is very useful in these cases. And of course, the locking is, we have to lock, I really like the consistency in the application. So using transactions, using repeatable read, and so on, it really helps a lot. But essentially, it has to be kind of a hot potato approach. It's like you grab it, but you have to release it as fast as possible. So whenever you build any kind of application, trying to group up things into like immediate execution and then just do everything else aside, it really helps for all the locking overhead and locking contention. And locking contention is one of the major things that also kills the bigger web projects. And dealing with that it's usually very important. So like PHP output buffering is really great so that users don't stall the PHP execution in the middle when print suddenly takes 10 seconds instead of nanoseconds. And of course, if there's some big change in database that has to happen, it can be just simply delayed and using some queue method and executed later. And so anytime lock is held on some specific set of data, other other views, other users cannot access that. And that hits so often that it also is quite a difficult problem. And this is let's say in case of replication, it's also everyone likes to spread the load by adding replication and adding nodes, and it's really the number one kind of solution to what to do once the load becomes intolerable for a single server. And that is where yet again a hack comes to serve the user experience by actually destroying the performance for them, but making them happier. One of the biggest problems with the replicated environments is that users might see data which is older than when they make a change, and they become so frustrated about that. They start like hitting refresh, fill the form again, and even it can take just 1 second. It's still quite often enough to make a user frustrated that his change didn't go through. So the easy technique is simply whenever a change is made in the replicated environment, look at what position, maybe what database server that user is connected to, the slave one, or just simply look at the replication position on the master. When did the change happen? And then store it in a session. And whenever any reads come from that user, just use that token for that small data and wait for the position for the slave to catch up. And that's usually sub-second, and that's usually not that noticeable for the users, but of course it kills the performance for half a second or a second. The requests become longer, but that's what users want. They are not always wanting, in these cases, when they make a change, they want to see it immediately. So this is the number one hack for like practical thing. Whenever you have any replication lags, like even small ones, 1 second, 2 seconds, if this is done, it helps so much and really reduces number of frustrated users. And of course, one of the easy things with MySQL, it's always nice to add comments that indicate which part of application is causing the change, and or like which part of application is sending in a query that is expensive, because not always the same guy who's looking at the database is actually writing that application. So adding the fragment of backtrace or the method that invokes the select call, it's usually very helpful all the time. So whenever we had to resolve some cases where users simply didn't know where that kind of object fetches come, why is some specific load is hitting the site so much, we just simply added the method in a comment, and we immediately saw what is happening. Simply extending that understanding, extending the trace of application and the whole stack to mark its belongings in the database itself in the queries. It's one of the most useful debugging techniques. And this is why using various query wrappers in application just to handle profiling, to handle marking, to handle logging of errors that is specific to database, it's really useful all the time. So this is why calling directly MySQL query in any API is not a good thing to do in any application. And of course, the main rule, whatever you do, your needs are the most important. It's not like any book is going to tell you, or any speaker will tell you how you have to do your application exactly. If there are some special needs, special loads, special access patterns, it's the main way is simply to be inventive and try to handle that in creative ways instead of just sticking to some rules and dogmas that don't really help. And of course, so if page view speed is not that important, if you want to do the more intelligent responses to user, do so. Nobody forbids it. But simply doing some of the things in really you have to think of all the different ways of how people are doing that, and instead of just sticking to some narrow dogma sets, just take a look at what others are doing. So don't listen to others, and maybe don't listen to me. So yeah, we can go either to questions or to lunch. Which is first? I see you want lunch? Hello, no questions. I guess that was boring. I have another slide. Look at this. I hope lunch is warm today. questions, I still look.
Are your slides online?
Oh yeah, they are. The link is actually over there, just the bottom, damasLT/UC. There is a huge workbook from my previous last year presentation, which was like 40 pages of text about Wikipedia infrastructure. That is probably slightly more interesting, but I kind of do that every year.